Hello, and you're very welcome to the Wednesday recorded lecture. And we're on to the second topic of topic 3. So it's topic 3B. So we will get started just with an introduction. And so this is what we did, what Yvonne did with you on Monday, or in topic 3A. So you looked at methods and the signature of methods. So primarily, a method is a piece of code that has a name. You write it once and then you can call it whenever you need to. And when they're written well, you can call them on different values. So a number of things we need to look at for the method. We have the return type. So in the signature, so if it returns a value, what type of value? So this is a promise to return a certain value. We have the name, which technically can be, any, like a variable name, in fact. But what you try to do is have a verb there, so it describes what it does, not how it does it, what it does. And the parameters are the things that can change. So the better use you make of parameters, the more reusable the method is. And we're going to see some examples of that later on as well. The body of the method, you need curly braces, no matter how small or big, even if it's one line. You have the method signature, then you have the curly braces, and everything within those curly braces is seen, will be run when you call or invoke that method. The definition then is what it actually does. So for instance, if you have a return type and it's an integer, int, during that body you need to have, the word return with an integer value there. So you have to keep good on your promise of what you promised in the return type and so on. So we looked at two examples. Well, the I's we looked at, the X's I'm going to look at today. And then, so what we're looking at is how do we write our own methods and how do we reuse them and use them and all this. So one of the first ones was the red rectangle, and we looked at kind of building that up from a very hard-coded method to one that was reusable. And then we kept adding in parameters to make it more reusable. So if you want to draw a red box, you could have a method that just drew a red box in a particular place, or you could have a method that said, tell me what color, tell me where to put it, and tell me what size. Okay, so you can parameterize all those as well. Okay, and just say times 2 then. You would have one parameter in, so you can think of the parameters as if you have a method, we'll call it void, I'll call it method 1, and you've int x, and you have some sort of code, and you return x multiplied by 2. Now you can see the parameter as a way of getting information in. I've disappeared there. I'm back. And the return then is the way of, sorry, that should be an integer. And the return is a way of getting the information out. Okay, so the parameters bring in the data and the return statement sends you out a data. So it returns, when you call that, actually what happens is the value of the, so if you call that and if you said x is equal to m1 4, that would give you back, so x at the end of that would have the value of 8. Okay, so the parameters are to get the information in, the return statement is to get the information back out again. Now, you don't need to have a return type. We've been using void all the time, and that's okay too. All right, so that's last week, and so today we're going to look at, first of all, we're going to look at drawing x's. It's kind of like the red boxes, and we're going to parameterize the thickness and so on. So just different things we're going to parameterize in that. Then we're going to write more of our own methods. An I grade, Celsius to Fahrenheit, product and cubed. Now when you see the capital letters and that's kind of the words of them. It's the names will always be lowercase. Then we look very briefly at debugging. We'll probably get into debugging a little bit more when we get on to IntelliJ, but debugging is a way that the compiler, processing in this case, can help us to look under the hood if there's things going wrong. You can always look under the hood even if it's going right, but you tend to only do that when it's going wrong. So the overloading then, that's when we are using the same name but with different parameters. So that's a kind of an addition with object-oriented that you can do that. And then a very brief venture into recursion. Recursion is where you define, in general terms, where you define something in terms of itself. So you can call a function, when you're calling a function inside in a function, you can actually call that function itself, and that's called recursion. But we'll more on. And then the strings, the object and the dot notation. So we'll see what we're going to do with strings is we're going to say, okay, here's a library. Here's a library that somebody else wrote. Call it a package in Java, and we're going to see how we manage those methods, right? Because when we write our own classes, we're going to have our own methods, and we're going to be able to use them in the same way, but we're going to see them without the worry of having to write the string package. Okay, so we'll just get on to okay, so in this one, we're going to this is what we've done. I've just gone through that there, so I'll just skip through this, and this is what will be next. We're going to look at the method example, the x's, and that's what we're going to do in this. Okay, so we want something like this to happen. Okay, so how we draw an x, if you remember, right, you would have, I think, done some of that in labs, and an x is very much, so if you're talking about, there's going to be two lines, two lines like that. So you have one line with x1, y1, And if we just call this x2, y2, and then you'll know from the geometry of it that the x will be the same as x2, and the y will be the same as y1. And in here, the x will be the same, and the y will be the same as this one. So what we mean by that is the x, remember, is how far it goes over, and that's not a square x, but it should be, you know. So if it was a square x, the x1 and the x1 here are the same, the x2 and the x2 here are the same, the y1 and the y1 here are the same, and the same here. Okay, so that's how we get a square x. Okay. So we're going to just draw one x, and as usual what we're going to do is just draw it hard code of it. So if we do that, we're going to, that's 1x. So if we want loads of x's, we'd need to do this. So this is the first one. So that's this one. This is the first one. This is the second one. And this is the third one. Okay. So that's great, but it's an awful mess because you don't want to be in the sense that you've duplicate code there. So at each point you have a stroke, you've stroke weight, and then you've the lines. And you can see here when we looked at now the lines are moving over a bit and all that, but basically a lot of things are actually the same. So the width of the width is the same and all that. So the width is always 60. You can see there from there. So the width is the difference between the first x and the second, and the length is the first and the second here. So they're all the same. They're all 60 by 60. Okay. So what are we going to do? It's all duplication. So anytime we've duplication, we need to think about how we can make this better and how can we see the patterns. So the things that are changing there, right? We have stroke is going from 160 to 0, and in a sense that is, you know, quite random values or whatever. The stroke weight is actually just going down or whatever, but again doesn't seem to be any pattern. The main pattern is within the lines. So here, you know, the width is 60 and the height is 60. We may have a different starting point. So we want to encompass that as if we can. So this is our first attempt, which is, we're not doing any parameterization here. We're not doing any, this is all hard coded. So this simply draws that, nothing else. Okay, so that produces that for me. The background gives me the light grey, and we're calling this on draw X. Okay. Okay, so one thing we could, our first attempt at parameterization is in the grey. So now what we're saying is, we're saying, well, maybe because maybe we want to send in the value and the color of the grey. That seems a reasonable thing to do. Okay, so we're going to do that now. So when I call that, because in the original one the weight for black is 0, so we're going to call that on 0. One parameter. Okay, so we can change one thing. Okay, the next thing then is the weight. So we could add the weight, because remember we looked at that and they were kind of a little bit random in a way. So now we have the grey is going in here and the weight is going in there. So when we say draw 0, that goes into the grey and that goes into the weight. Yeah? Okay, and that gives us that. So called by that, it gives us that. Right, so again, just a reusable, a little bit more reusable. And then this is the one where we're going to start kind of hitting heavy here. So in this one, we're making use of the pattern that we spoke about. So you can see here, what we're saying is, if you give me an X, and you can see the pattern a lot easier here. So, sorry, that's so you can see the pattern. Whatever the size is, you're going from X. So instead of using X1 and Y1, where you just using the size, it's a square X, so the length is the same as the height. So the next line, if that is X and Y, the next line, or the next point, X plus size and Y plus size, is down here. So that's our first line. And the next one, the line goes from X plus size and goes all the way back to X and Y plus size. Okay, so what you're using there is you're taking the, so this is size over here, and this is size over here, because it's a square X. Okay, so we're using that pattern. You can't use the pattern if you don't know what it is. So a lot of the time it's about maybe changing things a little bit so that you have an exact pattern as well. So and that's what we're trying to get you to do, to see patterns and to be able to abstract those out. Okay, so this is kind of where we want to be. So now with that, we can draw those 3 X's. But now you can see what's going on. You know, this is the, so we'll just take the first one. This is the color. This is the weight. This is the X. This is the Y. And this is the width. So you can see the first one starts at the top there. It's just because the weight is so yeah. So okay, so that's what gives you that. Now have a look at that, make sure you're okay with it, but it's so nice to use. Okay, but we're not going to stop there. So you can see that we can use this. Now what you'll notice about that is, as I said, there are some, even in here, in patterns in that, because the size is 60 all the time. In fact, you can see there that, you know, the X and the Y are, it's like 0, 5, 30, 20 and so on. So they're quite randomly spaced. If we want to group them together, we're going to look at this one, right? And what that does is it does this really nice thing with the loop. So this is meant to kind of bend your head a little bit, but you can see there, you were using the Draw X. Remember what the Draw X does? That's the colour. That's the weight. That's the X. That's the Y. And that's the size. Okay. So as I gets bigger, now remember with this as well, I multiplied by 10 is done first. So it's 200 minus I multiplied by 10. So as I gets bigger, this gets smaller. So it gets so it's going towards, so it's getting darker, in fact. The weight is getting smaller as well. So that means it's getting narrower, and you can see it's kind of more, it's more sharp as it gets in. Then the I is I, which starts at 0. The Y then is I divided by 2. And the 70. So you can see it's getting bigger and bigger and bigger every time. Okay, so what you'll find is you can play around with those values really as long as you leave your eye like that. It'll for your Y, and play around maybe with the values of the Y, the grey and the weight. You'll see kind of things happening. And as I would always say, always play around with that. Play around with the values. Try it less than 30. Try everything. Make sure you're kind of very au fait with it. Okay, and have a bit of fun with that. Okay, so that will give me that. And that is that one. Okay, so I'm just going to take about 2 minutes to set up for the next slide deck, and we'll just go on hold here for a minute. So just about 2 minutes, and we'll be back for that. Okay, thanks very much. Okay, so we're back, and we're going to take another example. You'll be between I's and X's, you'll have a lot of patterns looked at. So we're going to look at the I's again, and we're going to look at a pattern again about drawing a grid of I's. And again, it's about using the loop inside in this. So this is the single I, and again, it's hard coded, but you should be beginning to see the patterns, and the patterns, you know, this is, and these are written very much, you know, plus 10, plus 16. The next one then is, you can see that's there, 60, and there. Okay, so what you're talking about is a big white eye, a big white circle, then a black, and then a very small white. Okay, and you can see that if you take the center of the first one, the centers have to be different because you want to look over to the side or whatever. Okay. So we've looked at that, and then we parameterized that a bit, and we said, well, we've kind of seen where the pattern was. So instead of having like 50 to start with there, we have X and Y, and you can see, so this is pushing over the center of the eye over here, and then the Y is staying the same, except that the pupil goes up a little bit, so that's Y minus 5. Okay, so the black part is half the size, and that's very small then. Okay, so, and then you start them off with different, so this is basically your first, the first eye and the second eye. Okay, and so if we do this, we get all of the eyes. We have this nice grid. But you can see as well, right, if we have the grid, there's a lot of patterns emerging here as well. And so you can see 65, 65, and 65. And then you can see 20, 20, 20. Okay, so if we talk about them in groups now, you can see, and then we have our 44, there's 13 between there, and so on, and 13 between there. So the Y's are going down 30 every time. So again, you will get more used to this ability to patternize those. Now the other thing to be said is, once we go away from processing, we won't be looking at that exact kind of pattern matching, but it will be really useful to you for it to see you know, patterns in general, because that's how you parameterize, you know, and so on. So, okay, so if we want to do the eye grid then, now to do this, I just going to disappear for a moment. You should change the size of the display screen, because you won't see all of the eyes if you do this. But when you're looking there, you have your background, which will just give you the grey, and then you have your int row, and the row starts at 1 and keeps going, so you're going to get 1, 2, and 3, and here you're going to get you're going to get 1, 2, 3, 4, and 5. Now remember the way this goes. So it's going to go 1, 2, 3, 4, 5, while the row is 1. And then when the row is 2, and then I'll write this, you're going to get your 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So if you know, if just to recap on that, you come in here with row is given the value of 1, and then count is given the value of 1. Then you do your I count multiplied by 60, so that's 60, and row, so it's going to go 60, 70, which was the original one, right? And then you go back, and now you're at 1, 2. So, sorry, because you go back here, and you're going, I count now is equal to 2. So your X is, so what's happening is your row is not changing. Your row is not changing until you actually do 1. This is when row is equal to 1, row is equal to 2. Sorry, excuse me, but count is equal to 1. So I should have that in blue actually. So 1, count is 3, 4, and 5, and then you move down to the next row, and this is the way it looks on the right, that should have been, and then the rows are going to look like this, 1, 2, and 3. So what happens there is you've gone 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and then you've finished here, so you go back here and back here. I gets incremented then, so we're at row is equal to 2, so that's row is equal to 2 here, and then you start and you go 1, 2, 3, 4, 5 for that. So 1, 2, 3, 4, 5, sorry, in the second one, and then for row is equal to 3. Okay, so it's no harm again having a look at that. Just make sure to change the size of the screen, because you'll be doing all the work and you won't be able to see it, and we don't like that. So that is that one. So have a play around with that, make it a bit bigger, see can you do a 4 by 5 or something like that, just to see. So it's all about calling methods within loops, and in that case within the nested loop. Okay, so have a look at that then. All right, so the next one then is we're going to look at the idea of debugging, and I just want to show you this one here. So if we go to the laptop, and you mightn't be able to see, actually, just give me a moment there. Okay, so this lightly too. Okay, so you might be able to see that a bit better. Okay, so if I run that, you're going to see that. Okay, so okay. Now, if I want to kind of take the hood off that, right? What I can do is I can go up here to processing, go up here, sketch, and you can see there's a debug up here. Okay, there's a debug up here, and just say enable debugger. Now, a debugger is basically it's a help. You usually only use it when you have a problem, right? So that's why it's called a debugger. It's no harm to try and kind of work it out maybe before this. This debugger isn't absolutely, it's not the best one, but it's absolutely fine, and it does what you need to do. So what we do is we just click in. You see there, just click into that side here, and you'll see there's a little triangle appears there. And up here then, there's different ones. So we're going to say, okay, so just bear with. Okay, so you can see there, what I've done is, I'm just going to stop that and start it again. So I have it here when I'm calling I, right? And what I'm going to do is I'm going to either say step or continue. So I'm just going to say, first of all, I'm going to say continue. Now what this is this the display screen that I'm looking at? So I'm going to say step into that. And what that does is it goes through it goes into the particular place for me, and it goes there, and now it's going to show me the count, and now you can see the count. You can't maybe see it very well there because I'm if I make it any bigger, okay, you'll need to do this. So that's saying 1 and that's saying 2, and if I go continue again, it'll actually give me all of these things as well. Now another thing there, you see here, you can just go down here and you'll get all of your system variables as well. So it's no harm to do that. So you can see I'm not doing anything with the mouse at the moment. So mouse is in my bag actually, so it's not doing anything. So the width and the height you can see there is that. Okay, so what it does is it gives you an under the hood version, and it's actually really nice because you can actually see, you can see here there's a little arrow on the edge, and it actually shows you exactly where you are in the code. So you can see there, if I do a continue, it goes back up and it increments count to 5, and then we'll see it going back, and now row is 2, count is 1, then count is 2, then count is 3, and so on. So it's no harm for you to do that anyway, just to convince yourself the way the loop works. So it's limited to an extent, but it's actually quite good. And as usual, you need to get used to it by looking at something that actually works for you, and then you can move on to other things then. All right, so I'll just go back to the main one then. So these are all the things here, so you can see a bit more clearly there what I'm saying. So try the debugging by all means, right? Get in something that you think you know how it works, so it'll actually show you. And this is the little triangle. You just press on that once you have it enabled, and then so turn on debugger and you just enable debugging then, and click continue to get it started, and then step into. So continue is like the play button, and what happens is it stops whenever the breakpoint is. It's the breakpoint, it stops there, and then you're given the option, well, where do you want to go from here? So you could actually step over. There's a step over if it was calling the method, and it wouldn't go into the code, it just keep calling that method. So it'll get a lot more useful when we get onto IntelliJ. Okay, so have a look at that, make sure, convince yourself you're okay with it, and then that's grand. Okay, so the next thing we're going to look at then is we're going to look at methods that return a value. Okay, now there's basically different types of methods, and Java welcomes them all and processing as a result. So in Java, the methods are called functions, but in maths terms and more kind of programmy theory, the ones that are really functions are the ones that strictly return a value. We don't have to worry about that at the moment, but so something like Celsius and Fahrenheit, you give it values, and you get back a value. Okay, so we'll see how that goes. Okay, so in the previous value, the x's and the i's, the return type was void, and actually what we say there was no value returned because we don't consider a drawing of value. That's almost like, technically we call that a side effect, all right? Because it's changing the outside world, but it's not actually giving you back a value. What I mean by the outside world is showing you something on a screen, or it's printing something to a file, or whatever. Now we're going to look at, as I said, kind of more like mathematical functions. So what we'd like is something like this. So we have in our setup. Now remember, we can write all these kind of ones in setups because we're not listening for anything. This is just we're giving it a value and so on. So float Celsius is Fahrenheit to Celsius. Now in this case, okay, so if we just for a moment, right, think about functions you would maybe remember from maths or something like that. So you might say something like y is equal to sine x. Okay, and so you expect to put in a value of x there. We'll just say 90, and that will give you back a value of 1. Okay, now the point I'm making about that is that given 90, you will always get back the value of 1, and that's the point about functions like this. Now they don't have to be pure functions, but you put in a value and you get back another value. Okay, and there's always one value given at that time. Okay, so if you think about this one then, the Fahrenheit to thing. So remember we said you get the information in like that and you send the information back out like that. So as usual, as would happen normally in any method, so the Fahrenheit goes in and gets bound there, and then you do this formula, which basically it's Fahrenheit minus 32 multiplied by 5 divided by 9. Okay, and that is your result. Okay, so and then you just return the result. So basically this value is returned. Yeah, okay, so that value is returned, and so that's a float. We're giving in a float, so we expect, so it's reasonable that will be a float. When I call that then, I'm saying Celsius Fahrenheit, so 451 goes in there, which goes in there, and that's calculated as that. So then you put that value into Celsius. All right, you put the value into Celsius, and then you print out Celsius. Okay, so that's your Fahrenheit to Celsius. You can see there it's going in. That's the result, and that goes back up to Celsius. Okay, so that's the return type. So the return type, remember we said, is a promise to send that back. So if you're putting it back into a variable, you need to remember that. Now just a very slight aside there, and you can see, like, this is very like if I said y is equal to 25. Okay, it's just an assignment statement, but the thing on the right, remember when we were talking about assignment statements, we said evaluate what's on the right hand side. Sometimes that's just picking up 25, and sometimes it's going away and calling a function. So in this case it was calling that function. Okay, and then that gets printed out. Okay, so remember 451 gets put in, that goes all the way there, there, and out you go. Okay. Now I could have, instead of writing the top one, this one, oops, so this is what we did. We calculated our result and then we returned the result. And I'd say until you get used to it, do whatever works for you. But remember, this is actually what we're returning. We're just putting it into result and then returning. So you can directly return that. And that's okay too. And you get more used to that. You'd call it in the very same way. There's no difference on the outside in the interface at all. So you'll just get more used to doing things like that as you go along. Okay, the next one kind of similar in style, the idea of cubed. And now we're using draw here. It's not necessary to do draw. Well, if you're using text, it is, but if you just wanted it out in the console, you don't need draw. That's the difference. Okay, so here you have your cubed. Your cubed just takes in a number and returns that number cubed. Okay. The draw then, you're going to say number is equal to 5, and then in your text say number cubed is cube number. So that's the number 5 that goes in there. Then cubed is, that's that bit there, and then cubed number, and that tells you the position. So that's where it starts. Okay. So that's using your text and all that. But the main thing there is the way it's called. So that call, you don't put it into a variable or anything like that. You put it directly into that text statement. Okay. So that call of a function, if it returns a float, you can treat it like any other float. Okay. And that's kind of something you might need to get your head around as well. Okay. That's the return type. And you're putting that in there, cube number, and you get back 125. And that's what is printed then. Okay. Next one is product. So you can imagine where this is going. Again, we're using draw because we're printing it out to the display screen. But again, we have the return time of float. We're taking two numbers now. Obviously, we could just use the multiply, but this is just to get used to. If you take in two floats, you'll generally return a float, and you can see here what's happening. We're using the very same idea here. So so that's going to be 20.5 and 3.5. So that's going to return 20 by 5 by 3.5. That's 70. We'll say 73, roughly 73. And actually 71.75. Okay, so you can see here the product of A and B, B is 71, and this again is the position on it. So you're using a few different things together, yep, and getting going with that. Okay, so any questions with that, and we'll go on. Okay, so your next slide is going to be on recursion, so we'll just have about a minute hold over there, and I'll get back to you then. Okay, and we'll have a longer break then after the next slide deck. Okay, and now with sound. Thanks, Siobhan. So this time we're going to look at overloading methods. Very short slide deck, and then we'll take a break. So this is a really nice idea. We have draw X. At each, you see the point about this is, right, that at each point here, if I were to describe what we were doing, I'm actually drawing an X. I'm actually drawing an X in all cases. So it's a good name. So why don't we use it over and over again? But if we use it over and over again, how does the compiler know which to call? And basically, if you say draw X like that, it will look for that. If you say draw X 3, 5, just say, um 5, that will look at this one. No, it's not. Yeah, and there. And just say, if I say draw X 4, 5, 6, it's actually going to look. It's going to look. It's not that. It's not this one. I'm looking for one with 3 parameters. There's none, so that's not going to compile. Yeah. So there is, it does allow us. We have a unique definition of each of the draws, so the compiler is never worried about, which one am I to use. It's always very defined. Okay, same name, different parameter list. Okay, so here we have the method signature. Remember what the method is, basically the first line of the method before any code gets involved. And you can see there's no parameter here in the first one. There's an integer, 2 integers, and 5 integers here. Okay, so same name but different, and you can have different numbers or types of parameters as long as they're quite separate. So when Java is checking that a parameter list is different, it's not checking the name of the variables. It doesn't care, right? It's just the data type. So you might call, in all of your descriptions, you might say this is the level of grayness or whatever. But this is that's okay. It's the type is the important bit. So the data types must be different for method with the same name and number of parameters to be overloaded. Okay, correctly overloaded. Okay, so which draw method is used in this case and why? So if we have 0 here, you could argue that it's either, but actually it definitely can be an integer, so we're going to call the integer one. If I call it on 0.0, then it's going to call the second one. Okay, so it has basically, as long as it can mechanically choose, then we're okay. Okay, so that's that slide deck there. So what we'll do now is we'll take about 10 minutes. We'll come back and do a little bit on recursion and then move on to strings. Okay, so we'll say about maybe 10 minutes, or no, say 7 minutes. 7 minutes, and we'll be back then. Okay, thanks a million. I've done it again, apologies. So we're looking at recursion in the slide deck, and this is a massive area in computer science, but in programming. We're not going to do too much on it. We're giving you a little peek into it, and that is kind of enough. We won't be really asking you to implement recursion in the assignments, but it's just something very useful to look at. So here we are, and so this is one way of drawing 4 lines. Okay, so we have our where we start and the number of lines. So you can see here, this is not recursion now, before we get into recursion. So what we have is, we have line. You want to, in this case, we want to have 4 lines. So the num lines is controlling how many lines, and this is controlling the distance between the lines. Okay, so you can see from here that there's 2 different things changing, I and X start. Okay, so see if there's a, okay, so here what we're going to do is, this is just to get us ready now. This is just to get us ready for recursion. So we could, instead of incrementing I, we could decrement number of lines. Now this is just getting us into the way of doing the recursion. Okay, so eventually num lines will be 0, and then the condition will break. So because 0 isn't less than 0. Okay, so a recursion is contain a line of code that calls itself. So to do that, we have to be really careful about the base case. Okay, so if I just take an example of something you may have seen in maths, if you remember that long ago, it was a factorial, and we had this thing n factorial, or we'll just say 3 factorial, was given the value 3 multiplied by 2 multiplied by 1, right? And also 2 factorial was 2 multiplied by 1. So if you look at that, you could say, well, if I were to be clever about this, I could say that 3 factorial is equal to 3 multiplied by 2 factorial. Okay? And in general, I'm going to do this up here now, I can say that n factorial is equal to n multiplied by n minus 1 factorial. Now don't worry too much, we're just really giving you a peek into this. But the point here is that if I just leave it like that, it's going to give us an infinite loop. So before that, I need a base case, and the base case would be 0, and I can put in 1 as well, is equal to 1. Okay, and I'd need to put that in ahead of that. So you do a pattern match first and make sure it's not 0 or 1. We only do this for positive numbers, and otherwise you do that. Okay, so that's the example of a mathematical function in it. And okay, so if we go down to another example then, in this one, okay, so what we're going to do is, I'm going to disappear for a moment. So here we have our draw lines, and the draw lines are here, x and num. Now remember what we were doing with num in the previous one. In the second loop we were decrementing num. So if we start with 10,4, all right, if we start with 10,4, basically we want to keep drawing the lines while the second parameter or argument is greater than 1, because we don't want to keep doing that. So we draw the line at x, and then if num is not sufficiently small, because remember we're going to keep decrementing that, the way we do it is we call draw lines. Remember the x went up by 5 every time. Remember we had start x plus, and num lines went back by 1. So what you're doing is you're incorporating the increment and the decrement into the call of the function. Okay, so this is now a big kind of mind shift. So I would say have a look at it rather than trying to recreate it at the moment. We're just trying to give you a view in. The base case, if you didn't have that, it would keep drawing lines forever. Okay. So what we're going to look at is we're going to say draw lines. So the first time this happens, x is equal to 10, num is equal to 4. So you've drawn the first line, you can see it here. Then that's going to draw lines on 15 and 3, because that's your x and this is your num. So you've added 5 to that and taken 1 away. You then draw your second line here. Num is still greater than 1. So you're going to go, so again, you're going to call draw lines, add another 5, take 1 away here. You're going to draw your next line. Then the next line, draw lines 1 and line links. That draws the next line for you. It checks, is 1 greater than 1? It's not. That's the base case. So we finish. Now we've finished the base case, so we go back to the calling function. But as a kind of a side effect, the 4 lines have been drawn. Okay? So that tends to be the way it happens. We call it kind of like the triangle. It goes out and calls another one and calls another one. And until you've met the base case, you're still in, so the first draw lines is saying, hold on a minute until I'm finished my next draw lines. And then that goes on and says, hold on. And eventually that finishes, so that finishes, so that finishes, and so that finishes. Okay? So, have a look at that. It is... just have a look at it. Don't worry too much about it. You will be seeing it again. Okay, but not in this semester. Okay. So you can see it goes back like that. And then it's finished. And because we were looking at the side effect, the output has happened as well. Okay. So that's recursion. So we will just keep going straight on to strings now. And this is really important. The reason we do the strings is because it's a really good example of methods and how we call methods and so on. Okay, so this slide deck is going to look at primitive types. We're going to look at car, and we're going to look at the object types of string, and we're going to see what is the difference between them, because we've seen both now, right? And especially with string, we'll see what both of them and the differences there are. Okay, so first of all, we look at characters, and as you know, well, hopefully you know, that Java has 8 primitive data types, which is really, really small actually when you think about it. So we have to get everything in there. But so what we need to do is we need to build structures around those and so on, and kind of play around with them. But so these are primitive, and the character one is the one we're interested in at the moment. And what we say is it's delimited by a single quote. So you can see there that the single quote, so car letter, these two here, single quote. Okay, so that's the way we do it with the primitive one single character. Now that does lead as well, we have things like \n, which are special characters, and \n, special characters, and the / is to say we need, this is one outside of the normal one, and the idea there is there's like so many different characters that we need. So if you look at any keyboard, you're not going to have a new line in it, whatever. And when you're going from one language to another, basically what those keys are is they're keyed into one of the characters. And as you can see, right, there'll be loads of special characters, like even the euro sign and all this, that will be programmed into those. And the way that's done is there's a special Unicode there, as you can see there, and those numbers, you can actually look them up and see what special characters are there. So it all works. So the single quote is for one character, but the / means that you're either using something like the \n, or the U means it's the code for it. So if you have big capacity of how many characters you have, but the real simple ones we'll be using just simply a single quote. That's the important thing, that it's a single quote. Okay, so these are all valid. Okay, we could assign little n or uppercase n. We can't do that unless, of course, n is another character, which there'd be no point in that. Please don't call any characters n, because never call a character just a single letter, because it's confusing. The double quotes are not good, right? We'll see why in a minute. Basically, the double quotes mean a string, and a string means a whole load of a list of, or a collection of characters with other control characters in it, to say it's the end and so on. And it's the same with not. One character, single quote, and that's it. Okay, so this is what I was mentioning later. It's actually a single, it's a 16-bit Unicode character, so you have a big range, and you can look up those links there if you want to see other ones, and you can see that A, for instance, is 41, and little a is 61. So that's, there's an order in those and so on. Okay, and because of that order, even though please don't do this, in the sense that you can do this, that it's using the Unicode value, and when you say letter ++ here, that will actually print out all of the alphabet. Okay, because letter ++, even though you're seeing it as a character, but that's really important, the underlying bit of it, because we need to be able to judge the relative order of letters and so on, but more and on about that as well. Okay, so the string then is delimited by double quotes, and it's delimited by double quotes, for instance, as a sequence of character. It's a really handy data structure to have, right, or an object type to have, because we can if we're doing inputs, everything can be seen as a string. So an address and any of those mixed kind of types, they can all be seen as strings. It's an object type, which means somebody somewhere has written all the code, like you've written the class, any classes you've written, Spot and so on. Somebody has written the code for a string, made it publicly available, and now you can use everything about it and the methods and so on. So the Java platform, any of these are called packages. So it's the string package, and it's all about writing, creating and manipulating strings. So there's other ways of doing this, but the simplest way, and you do get strings. Strings is a special case, and you get that for nothing. If you know what I mean, you don't have to do any extra setup for it. And you can put in hello world. Now, the benefit of the strings is you can put as many characters as you want in it. You mightn't think that's special until next week when we look at the primitive arrays. So, valid use, string, str, I am a sentence. Okay, string word is equal to dog, or you can have a letter in there, a single character, but that is very different in type than the character. Okay, they're two different things. You can do different things with them. Invalid use, no double quotes around n, of course, unless n is itself a string. Single quotes won't cut it. It doesn't build it up to a string from that. And a string letter, why is that wrong? And we're going to talk about this. All classes that you've written should start with a capital letter. All right, and so that's why that's wrong there. Okay, has to have a capital letter. All of our objects are going to. Why is that? It's a convention, because then when we see something like string with a capital letter at the beginning, we know it's an object type. Okay, so primitive types versus object types then. This is what we know of our primitive types. We have int I is equal to 17. Directly in memory, we have I associated with 17. Just say with the object type string hello, the problem with that is that even as high goes through the program, we could add something onto that or take something away. So we can't be sure of how much memory we need for it. We know in the integer we need so many bytes depending on the size of the integer and so on. But in the object type, we can't be sure. So the way it's actually managed is that we don't actually have the value in the box in memory called high. We have the address of where the string is held, and that will be held in contiguous memory locations starting at that point. Okay, and the good news is you don't have to remember any of that. Well, you remember it to understand it, but that doesn't affect the way you talk about it. You talk about it then as if it's a primitive type. But when we go updating and things like that, and when we look at the primitive types that we're writing ourselves, that'll become important. Okay, so with the object types, the variable holds the memory address of the object where it's located, and this is called a reference, or the address. So it's like having the, instead of having a present, it's in the post and there's an address in the post, so you just need to go to the address and get it. Now, if we say A is, or B is given the value A, in primitive types, that means that B will eventually have the value of 17. If I say A is given the value, or sorry, B is given the value A here again, what that means is it's given the same address, which means that if I change B or A, I will change hello. Okay, so it's quite different, because once in the primitive arrays, once they've been allocated, there's no connection. But here, they're now connected. They now have the same address. That's really useful later on, because if I'm looking at a collection or whatever, I can pluck one out, just give it a name, and then I can make the change with that name. Okay. So just remember that. So it's only the value goes with the primitive, and it's the address in the primitive objects. Okay, so there's a bit to that, but we'll be coming back to that, and it'll become maybe hopefully a little bit more useful to you on that. Okay. So we're going to look at strings and their methods here. So this is the second part, and this is this slide deck on it. So okay, so we'll get going then. And the first thing is about the strings are objects. So objects are software structures. Remember this from your spot and so on, that combine variables with methods. So we have the data, and then we have the things that work on the data. Every string object has a built-in method that can capitalize its letters. So there's, in the same way as every spot that was created, you were able to draw it, or you were able to do it, whatever. Every string object has a number of methods that the person that wrote the string class, which we then call a package when it's made publicly available, it has loads of other ones as well. So have a look at that. And one of the big things about Java is the number of libraries it has. That's really, really good. The problem with that is if you start looking at libraries, you can get absolutely down rabbit holes and everything. So what we're going to do is we're going to say this is the first API, or the interface. So remember what this will give you. It'll give you a description of what each of the methods does. It doesn't, at the interface level, give you how it's worked. Now that is actually publicly available as well, but that's a separate issue. I'm not going to go through that there, but have a quick look at it, and what you'll get is a list of all the possible methods that are available to it. So that's the general application. Then this for strings, and have a look at that. And just so the way we're going to do it is we're going to introduce you one by one, and then you'll eventually be able to kind of look them up from seeing things on different places and so on. So what methods are available? So you will see something like this, except a lot more there's a lot more information around it. These are some of the methods that are useful to us in string. So for any string, and remember that's a double quote, hello world or whatever, we can get the length. Now the return type is really important. That is going to send back the length, or the number of characters in the string. The number of characters, the length of the string. To lowercase, you have a string, and if you call the to lowercase, it'll just convert everything to lowercase. Similarly with uppercase, okay, it'll put it to uppercase. Trim just returns everything with just the start and the end space is gone, because sometimes when you're reading stuff in, it kind of stuff comes in at the beginning and the end. Substring is really handy. That will take a substring from that beginning at the bin index and ending at end index, and this caret then actually will send back a char at a particular index, because the string and we'll see from next week in the arrays, there will be indexes, there will be positions of each of the characters on that. There's loads of others that you can look at there as well. Okay, so how do we actually call these? So we have internal and external. Okay, so in here we were able to, when we had our draw x, we were able to just call draw x, because it was inside in the same file, it was inside, and it was available to us. So we just called the method. We call this an internal method call. It's in the same sketch, as we call it, in processing. So if we can see it, we can use it within that scope. So it calls that, and it does all that. Draw X is a method call. The sketch has the method with that in it. It invokes the method, and because we just invoke it, it's an internal method call. And we just have the syntax method name parameter list. Now remember, when you're calling a method, you never give the type. You never say int method name or whatever the type. You just call it with the values. And this parameter list is going to be a list of values, be it a variable, but it's never int x. It'll just be either 10 or a variable with a number in it. External, this is what we need to see. So if we have a string called Joe Soap, and you can see there that length returns the length of the string. Now the big issue here is I could have 50 different strings, different names. So I could have name 1, name 2, name 3 or whatever. But I want to particularly get the length of this one. So for an external call, in other words, I'm here in my program, but I'm using strings methods. Okay, I'm using strings methods. So the way we do it is like this. We have our object, and by that we mean name. And then we say, in that object now, call this method name. So if we want to find out the length of that, name.length. Because this is the name, this is the method. That method is available to every single string object. Every single string object. So which one which name do you want? Joe Soap or the other one that was set up? No, you know it's Joe Soap because name is Joe Soap. So that's going to return 8. Now we haven't done anything with this yet, so it's not going to print it out or anything. But we could print it out, or we could, use it in a loop or do something like that. Okay, so that's really, really important. So the string came from outside, as some of your classes will eventually do as well. So when you have an object of that type, you need to specify which object you want that method run on. Okay, so that's the object, that's the dot, and the method name. No parameters in this case. Okay, so the dot notation then, it consists of the name, object, the dot, the length, and the parameters. There's no parameters this time. Okay, so that's the particular object. Remember, we have one class, string is the class, many, many objects. The one we have at the moment is called name. Okay, so some methods then. I could say this, right? I could say string message. I wonder how long this message is. And I just say print message.length, and I get 34. So again, I would suggest that you get used to this, change the message, see what comes up, and so on. And you don't need draw or setup or anything for any of those. Now, that's a nicer print statement, and it's one that you will find useful. So remember, println takes in a string. So what we're going to do is we're going to make a big long string out of this. We're going to say the string starts with the string it is. Then there's a plus, which just says, and add this on. The message length is a number. Because it's in the middle of a string, it actually puts that in a string, so that becomes a little string as well. But we'll see that happening over time. And then there's another string added to the end of that, or appended, called characters long. So what's inside the bracket is a new string called, and the new string reads, it is 34 characters long, and then Println prints that out to the screen. Okay, so Println expects a string, it gets the string there and then prints it out. And you're using a string here, and you're using a string method as it happens. Okay. This one here, I wonder how long this message is. If you want to, the plus is yeah, it's hidden there in the thing, but you can see the plus there says, give me the message at the end of that. Okay, that's actually a string as well, so there's no problem with it. We call that plus actually concatenation. It puts two strings together. Just be careful about this. You can see the way I've a space there. If I didn't have a space there, there'd be no space in it. So when you're doing that, so it would have been all on top of each other, and you'll get used to that as well. Same with the lowercase. I wonder how long this message is, and so on. Trim. You can see here with the trim, there's spaces in front and behind. So what I can do is the original length of message, or the length of the original message maybe, the trimmed message then, if you just say, make another message, string object, trim it, and now figure out what length it is. So we've the original length and the trimmed length. So you just have, print the two of them out. So the first one says the original message is HTTP not found, is 33 characters long, and the trimmed is 24 characters long. Okay, so what you're doing is you're making nice, now you see the way you, so the probably needed to put in the square brackets there ourselves. That's not shown there, so there should be square brackets if they're appearing there. Okay, and that's it. Okay, so just in summary then, if we just go through the summary one. This is what we did. We looked at the X's first, and then we looked at the iGrid, Celsius to Fahrenheit. So what were they? They were functions with return types, product and cubed. We briefly looked at debugging, looked at overloading. How can this work? How can we say draw X with loads of different meanings of, well, they always draw an X, but with loads of different data help. And then we looked at recursion very briefly again, and the strings. Now it's really important that you get the dot notation and the object and so on. So the dot notation, because when you are using classes inside, you will need to have a look at that. Okay, so that's it for today. Thanks a million for logging on if you're live, and if not, for watching later. And Siobhan has been on Slack. And just to mention as well that the first assignment, we will be publishing it. We'll be publishing it in the next day or two. So again, as soon as that is gone, you know, as usual with the labs and everything, there's a good detailed spec on it, right? And the spec includes things you're not allowed to bring in, as well as what we're asking you to do. So just have a bit of time reading it. It might seem like the spec is long, but just have a bit of time reading it before you start, and then you'll see. Okay. Also, don't try and start it before you've got up to date on stuff, and should be grand. So you will have the reading week for it, and so we're on next week again. Then you have the reading week, and then after that we'll be going on to IntelliJ. So this assignment is on processing. We finish the assignment and then we move on. Okay, so you'll be just handing up the assignment the weekend before we start on IntelliJ. All right, so but anyway, there's another week to go on processing, so we've a bit to go yet. All right, thanks a million, folks. We're nearly up at 2 now, so I will stop streaming and I will see you next week. Take care. Bye bye.